Good afternoon, everyone. Today we are going to start the last week of assignment class, a tutorial class, and we will be starting in 5 minutes. Let's start with today's session. Okay, so first question is the materials used for sorbing the solutes are known as sorbents. Is it true or false? The materials used for sorbing the solutes are known as sorbents. The answer is false because sorbets are called the which absorb the solutes, right? So these sorbing solutes are called the sorbed solutes are called sorbets, and the materials used for sorbing the solutes are called sorbents, right? So suppose this is uh, the surface and these are the molecules absorbed here. So these solutes, these molecules will be called the sorbets and the surface is the sorbent. Okay. Next question. So that is why this is false. Next. Which one is the industrial application of adsorption in liquid purification? Which one is the industrial application of liquid purification? So, the application of adsorption in liquid purifications. So, we will see removal of sulfur compounds from organic solution. So, there is a solution, right? So, it is nothing but the liquid purification. Next one, removal of sulfur compounds from gas streams. But gas stream is not liquid, right? It is gas purification. So, it is wrong. Removal of solvents from air. Air is also one type of gas, right? So it is also wrong. Next is the p-xylene separation. P-xylene separation is the liquid bulk separation. So this is also true. So this is a multiple choice question. Liquid purification adsorption examples are removal of sulfur compounds from organic solution and p-xylene separation. Next, removal of nitrogen oxides is an example of adsorption for gas purification. Is it true or false? Removal of nitrogen oxides is an example of adsorption for gas purification. Is it true or false? So, removal of nitrogen oxides. So, nitrogen oxides are also gaseous, right? So, it is definitely an example of gas purification. So, it is true. Next, what is adsorption? So, now we'll come to the definition of what is adsorption. So, we'll see this from a video. Okay, so you can see the subtitles also. So at first, adsorption looks like it's just stuff sticking to other stuff, right? Like this in the image. But if you take a closer look, you will see that there is more to adsorption than that. What is it? Adsorption is the adhesion of particles on free surfaces. Adsorption happens when atoms, ions, or molecules attach to the surface of a substance without entering it. So you can see that how these particles or how these molecules are getting just attached to the surface with the adhesive force, not they are entering, not they are penetrating into the surface, right? So what is written? They hang out on the surface like this. An example would be chemicals in a liquid sticking to a solid surface. So here you can see that an image like this in your textbook, ions, which are chemicals with a charge that are attracted to soil particles. It's a bit more complicated than just stuff sticking onto other stuff. So it has an outer sphere, it has an inner sphere. So how are they attached? It looks like some of them can easily be knocked off or exchanged with other compounds in the solution, while others are holding on tightly. You can see that all the molecules are not getting attached tightly. Some of are getting easily detached also. You can clearly see at this view how the hydration spheres surrounds the outer sphere complexes and not the inner one, right? We call it a hydration. Water is dipolar, which means a water molecule has a positive side and negative side, that is the oxygen side. An ion bound by outer sphere adsorption is surrounded by a hydration sphere. a collection of water molecules that are physically attracted to the ion because of its charge. Hydrogen spheres can form around both positive and negative ions because water has a positive as well as negative end, right? So you can see that in the right side, when there is a positive charge, oxygen part is attaching to them, and when there is a negative charge, hydrogen parts are attaching to them. We see water molecules gathering around the cation and anion, clearly showing the different ways they attach based on the polarity. Opposites attract just like with magnets. Since water has a positive and a negative side, it can align with either of them. The same physical force attracts the water molecules with ion towards the charged solid surfaces and soils. The water is acting as a buffer between the ion and the solid mineral surface. The ion sticks to the surface but only loosely, so it's easy to remove again. Right? This is what happened during ion exchange. So ion exchange is also another type of adsorption, right? It's like a chocolate covered pretzel. Chocolate is stuck to the pretzel, but you can easily chip it off. Although that seems like a lot of work to eat a plain pretzel. We say hydration sphere, but the ion doesn't need to be completely surrounded. Okay, it can also happen like that. We say even just one water molecule between the ion and the surface is considered outer sphere adsorption. Right? Outer sphere adsorbed ions are easy to remove. They can be knocked loose by physical force, reabsorbed back into the solution. Absorbed by plants or even leached away and replaced by other ions with a similar charge. Since the adsorption process is entirely physical, it is called physisorption. So you can see that based on the polarity, they are attaching to one another. That is why it is called physisorption. We will talk about these things later in more detail. But for right now, you just without water, though, something different happens. The ion shares some electrons with the surface like this. This is called the covalent bond ligand exchange or anion penetration. This means that a brand new substance forms at the boundary of the surface. The formation of a strong covalent bond during adsorption creates a new chemical compound. So this is process is called chemisorption. They are chemically bonded to the surface. Previous one is physically bonded to the surface. That is why they are easily detachable. Monodentate inner sphere complexes attach at one point. Bidentate complexes attach at 2 points. Polydentate complexes attach at 3 or more points. In adsorption, the more dentate links, the stronger the bond and the harder it is to free the molecules or adsorbed ion. And in chemisorption, you don't even need a charged surface. It's like baking a cake. You start out with flour, eggs, milk, and sugar, but once you bake it, you can't separate the ingredients, right? Physisorption is like the chocolate covered pretzel. Chemisorption, which is fusion, is like the chocolate cake. Anyway, this new substance blocks the ion away, so it can't be knocked away from the surface or taken up by plants or bacteria. Okay, because they are permanently bond or covalently bonded. The rate at which these happen is different too, which is why we have to run so many adsorption experiments. Outer sphere adsorption is physical process. It's fast and all it needs to occur at dipolar molecules like water and a charged surface. Inner sphere adsorption is a chemical bond, so it only happens in more specific circumstances, right? With naked eye, adsorption may look like just one process, but when we go into the molecular level, we can see it's actually very complex. These two processes have a lot of implications. Whether fertilizer and nutrients can be used by plants, what percentage of impurities can be caught by a water filter, and much more. It's all part of the wonderful world of adsorption. Okay, so this is adsorption. Next, we'll see the difference between adsorption and absorption. The terms are very similar, but don't get confused. The processes are different. So now there is so adsorption is a process of incorporation of atoms or molecules of a substance in one state into another substance of a different state, as you can see here, right? A liquid is falling on the solid and entering the solid through small pores on the surface of the solid. This is the process of absorption. So this is the absorption. Okay, where one state is attached to another state. The key point here is that both the substances should be in different states, like liquid is absorbed by solid or gas can be absorbed in the liquid. Second point is that it's the volume phenomena, meaning the liquid is entering the volume of solid instead of just staying on the surface of the solid. So it is kind of entering the bulk phase of the solid, or gas entering the bulk phase of the liquid. Okay. So these are two important. Example is softening of a biscuit. If you take a biscuit and put it in open air, after some time you will see that the biscuit has become soft or soggy. It's because in air also water is present, so the biscuit absorbs the water from the air and stores it inside it. So if you touch the biscuit, you will not feel the water, but it is actually absorbed inside the volume of the biscuit, which is an example of absorption. Second example, you can see swelling of resins. If you put resins in water bowl and you see in the morning that your resins have swelled up, it's because of a process known as osmosis, which is basically the absorption of the water inside the resin through the permeable membrane of the resin, which causes the resins to swell up. Now, adsorption is the process of addition of atoms or ions or molecules of a gas, liquid, or dissolved solid onto a surface of a solid, as you can see here, the liquids are falling on the surface of a solid, but they are not able to enter the volume of the solid. Instead, they are getting deposited on the surface of the solid, right? So the key point here is that one of the substances should be solid because the molecules are atoms of gas, liquid or the dissolved solids will adhere on a solid surface. Second point here is that it's a surface phenomena. So all the other materials are liquid or gas or dissolved solid adheres only on the surface. It cannot enter the bulk volume of the solid. So it's a surface phenomena. Okay, so these are the main two differences. Absorption is a volume phenomena because it is absorbed inside the bulk phase, and in case of adsorption, it is absorbed at the surface. So it is a surface phenomenon. And in case of absorption, there has to be two phases, and in case of two different phases, and in case of adsorption, one phase has to be solid, right? So now we see the examples of adsorptions. First one is, you can see a non-stick coating in pan. It is basically the adsorption of a solid on the surface of another solid. Here you have a material known as Teflon, which is coated on the material of the pan, which makes it non-stick, right? So that is adsorption. Second one is misty windows. Water molecules cling to the glass windows during the time of fog or mist. Even though some moisture is always present in the air, occasionally water molecules bounces against window and a small electric attraction makes it stick there. So over time these molecules pile up and form droplets. When they become sufficiently heavy, the force of gravity becomes greater than the stickiness and the drop rolls down the glass. So this is basically a liquid adhered on the surface of a solid glass. Okay. So this is the difference between absorption and adsorption. Next, what are the types of adsorption? So mostly ion exchange, chromatography, these are the types. So this is the ion exchange resin, as you can see. But inside it, there are solid resins are there where which is negatively charged. That is why positive ions, that is cations, are surrounded by them, and in the second layer, negative ions are there. Okay, now they are getting attached. Now you can see that when new solution is coming, they are replacing the white anions, right? You can see that red anions are replacing the white anions. Red and green anions are replacing the white anions, right? So they are exchanged. So they are replacing the molecules and getting attached. So you can see how they are replaced. Now again white are coming and replacing the previous one. So that is a continuous replacement of the ions. Similar type of ions are done in ion exchange. And this is happening because of the adsorption, right? You can see. So this is ion exchange. Next one is the chromatography. Adsorption, chromatography. So you can see this is the mixture of compound, this is adsorbent, and it is based on the principle of differential adsorption. Different compounds are adsorbed on an adsorbent in different levels. That is adsorption chromatography. Adsorption chromatography two types: column chromatography, thin layer chromatography. In column chromatography, it involves separation of a mixture over a column of adsorbent. The stationary phase is a solid like alumina, silica gel, etc. A slurry of the solid is filled in a long glass tube provided with a stopcock at its lower end. The mixture to be separated is dissolved in a suitable solvent and the solution poured over the adsorbed column. As the solution moves down, the compounds are adsorbed on different parts of the column. The most readily adsorbed compounds are retained near the top and other compounds come down to various distances in the column, thus resulting in a complete separation of the particle. The adsorbed compounds are then eluted by the passage of a series of eluents or solvents. The compounds at the bottom of the column which are less readily absorbed are dissolved first, and more readily absorbed compounds at the top are dissolved later. The solutions of these compounds are collected in different containers and evaporation of the solvent, the different compounds are recovered. On evaporation of the solvent, the different compounds are recovered. So this is a layer 1 component, this is layer 2 component and layer 3 component. All the components are separated with the column chromatography adsorption. Right? So this is the chromatographic adsorption. This one is the ion exchange chromatography. So chromatography is a difference between separating the different particles with the help of ions also. So these are combined here. What is ion exchange chromatography? So ion exchange chromatography is a chromatography process that allows the separation of ions and polar molecules based on their charge as well as other forms of chromatography. In ion chromatography, there is a mobile phase which generally consists of buffer solution, right? And there is a stationary phase which consists of a matrix that contains charged ionizable functional groups. This type of chromatography is subdivided into an ion exchange chromatography and cation exchange chromatography. Ion exchange chromatography ion exchange chromatography captures negatively charged molecules are attracted. Negatively charged molecules are attracted to a positively charged solid support, which is usually beads that provide a positively charged surface, okay, such as resin, quaternary ammonium. Okay, so this is in cation exchange chromatography, positively charged molecules are attracted to negatively charged solid support, which is commonly beads that provide negatively charged functional groups such as resin methyl sulfate. You understood? Ion exchange chromatography is frequently used for the separation and purification of proteins. The basic process of this chromatography can be represented in 4 steps: conditioning or equilibrium of the stationary phase, sample loading, washing, and dilution of and elution of retained molecules. The first step is the equilibrium of the stationary phase to the desired start condition. Start conditions: the pH and ionic strength of the sample buffer are selected to ensure that when sample is loaded, proteins of interest bind to the medium and as many as impurities as possible do not bind. Therefore, the same buffer is used for the equilibration of the stationary phase. When equilibrium is reached, all stationary phase charged groups are bound with exchangeable counter ions such as chloride or sodium. You can see how they are connected. When the column is equilibrated, the second step is sample application. Depending on the pH of the environment, proteins may carry a protein protein negative charge. So second order is the loading, right? pH of their environment. Proteins may carry a net positive charge, a net negative charge, or no charge. This net charge can be determined by comparing the pH of each protein with the pH of the buffer solution. Okay, buffer protein. Buffer proteins are large biomolecules consisting of one or more long chains of amino acid residues. Amino acids are organic compounds that contain the amine and carboxyl functional groups along with the side chain specific to each amino acid. Depending on the pH of the environment, the amino group can be protonated and become positively charged. Okay. Protonated means the one hydrogen will attach. And become positively charged. The carboxyl group can be deprotonated and become negatively charged, and the side chain of some amino acids can become positively or negatively charged due to the gain or loss of protons. So, the net charge on the molecule can be positive, neutral, or negative. The Ice electric pointer pH is the pH at which a protein carries neutral charge. At a pH below their isoelectric point, proteins carry a net positive charge, and the pH above their isoelectric point, they carry a net negative charge. In this example, the pH of the buffer is equal. 5 consequent protein A has a net negative charge, and both protein B and C carry a net positive. You can see this, right? B and C carry a net positive charge. In addition, protein C is more positively charged since its pH is higher than the pH of protein B. If we apply cation exchange chromatography, protein that has a net positive charge, it will bind to the negative charged beads of the stationary phase. On the other hand, uncharged proteins or those with a net negative charge would not bind. They pass through the column at the same speed as the flow of buffer. Okay, so you can see. When all the sample has been loaded, the next step is column washing. The column is washed with start buffer like this to ensure that all non-binding proteins have passed through the column. When all the samples has been loaded and the column washed conditions are altered in order to eliminate the bound proteins, most frequently proteins are made by increasing the ionic strength of the buffer or occasionally by changing the pH. As ionic strength increases, the salt ions compete with the bound components for charges on the surface of the media, and one or more of the bound species begin to value and move down the column. The protein with the lowest net charge of the selected pH will be the first ones from the column as ionic strength increases. Similarly, the proteins with the highest charge will be more strongly retained and will be the last one. Protein B has the lowest net positive charge, so it can be eluted first. Then protein C with highest net positive charge. It can be eluted next by increasing the salt concentration. Okay, now three proteins are separated. Also, varying the pH of the buffer can be used to affect separation and to elute the irritant proteins. The pH of the protein B is equal 7 and pH of protein C is equal 9. So, if we add a buffer with pH above the isoelectric point of protein B and below the isoelectric point of protein C, the protein B will become negatively charged and can then be eluted, and the protein C is still charged positively, consequently still retained. Next, protein C can be eluted if we apply a buffer with pH above its isoelectric point, so it becomes negatively charged and it also will pass through the column. So that is the ion exchange region. Advantages is only one interaction involved during the separation. Another advantage of ion exchange is the predictability of elution patterns, during the ionic strength or the pH. There is different forms of gradient protein. So this is your ion exchange. So you can see that how this ion exchange occurs. Next, give some examples. Give some examples of ion exchange adsorption. So, ion exchange adsorption examples are water softening, water demineralization, then recovery of uranium, from acid leach solution, then recovery of antibiotics, vitamin, from fermentation broths. Okay, so these are some of the examples of ion exchange where the ion exchange resins are used. Chromatography is used in the food business. Is it true or false? Chromatography is used in food business. It is true. Okay. How are sorbents chosen for industrial applications? How are sorbents chosen for industrial application? So the sorbents has to have a high selectivity towards the molecule, right? High selectivity to enable sharp separation. Second one is the high capacity to minimize the amount of sorbent needed. 3 is the favorable kinetic and transport properties for rapid sorption. Then hardness and mechanical strength. Okay. Fifth one is the free flowing tendency. Free flowing tendency for ease of filling an empty vessel. Sixth is the high resistance to fouling. Easily regenerable and low cost. So all these points are important to note when sorbents are chosen for industrial application. What is used to increase the surface area for adsorption? So to achieve a very large surface area for adsorption per unit volume, highly porous solid adsorbents with small diameter interconnected pores are used. Okay. So suppose this is a surface or solid. So pores of very small diameters has to be there. Pores of very small diameter has to be there on the surface of the solid adsorbent. It has to be highly porous. Okay. Next, the porous structures can account for up to 80% of the volume of the material. The porous substructures can account for up to 80% of the volume of the material. So, this true or false? The answer is false because it is not 80%. It is 50%. So, the porous structures can account for up to 50% of the volume of the material. Next, during adsorption, the solid adsorbent becomes what with the adsorbate? During adsorption, the solid adsorbent becomes there with the adsorbate. The answer is saturated or nearly saturated. Okay. Next question. Removal of adsorbates can be achieved by changing dash. Removal of adsorbates can be achieved so adsorbate, we have seen that adsorbates can be removed also. But how they can be removed? by changing the pressure or the temperature. Okay. Next, adsorption is an dash process. Adsorption is a dash process. The answer is exothermic. The answer is exothermic. Why? Because the molecules are attached to the surface, the molecules lose their entropy. So that is why entropy decreases and it generates heat. That is why it is an exothermic process. Next, what is heat of adsorption? What is heat of adsorption? What is heat of adsorption? So, just we have said that adsorption is an exothermic process. So, during adsorption process, the residual forces on the surface of absorbent decreases. It means surface energy increases. Sorry, it means surface energy also decreases. This decrease happens in the form of heat. This decrease happens in the form of heat, which is called heat of adsorption. This is the physical significance of heat of adsorption. Now, what is the actual definition? Actual definition is the amount of heat evolved when 1 mole of any gas is adsorbed on a solid adsorbent surface. Okay, so this is the definition. This is the heat of adsorption. Next, heat of adsorption is always positive. The answer is false, because heat of adsorption is always negative. Okay. Next, what are the adsorbents used in adsorption? What are the adsorbents used in adsorption? So different types of materials are used as adsorbents, like activated alumina, then silica gel, activated carbon, molecular seized carbon, molecular seized zeolite and clay. These are all used, or also there is polymers and resins. These are all used as the adsorbent. Classify the pore size. We have said that for adsorption, the solid surface has to be porous. So, depending on the pore sizes, there are three types of pores. First one is the macropores. From the name itself, you can understand that here diameters is in 5 nanometer range. In the mesopore, 50 nanometer range. The mesopore, the diameter range is between 2 to 50 nanometer, and in the micropores, the range is less than 2 nanometer. Okay. So this is the differentiation or classification based on the pore size of the adsorbent. Next, what adsorbent is used as desiccant in packing? What adsorbent is used as desiccant is in packing? So, what adsorbent is used as desiccant? The answer is activated alumina. Activated alumina is used. Okay. Next, silica gel is used in removal of fluorine in alkylation process. Silica gel is used in removal of fluorine in alkylation process. Is it true or false? Silica gel is used in removal of fluorine in alkylation process. Is it true or false? The answer is true. Next, what are the uses of activated carbons? So, activated carbons are used in multiple cases. It is used in water purification. Okay. Removes nitrogen from air. Hydrogen from syngas. Ethene from methane plus hydrogen. Vinyl chloride from monomer. From air. Odors of gases. Solvent vapors, removal of solvent vapors, removal of sulfur oxides, nitrogen oxides, purification of helium. It is helium purification. Cleanup of nuclear of gases. Cleanup of nuclear of gas. Okay. So these are the multiple or various uses of activated carbon as adsorbent. Next, which is used to remove water from azeotrophs. What is used to remove water from azeotrophs? The answer is molecular sieve zeolites. Molecular sieve zeolites are used to remove water from azeotrophs. Next, what are the uses of polymers and resins in adsorption? So here also they are used in water purification, purification of steroids, amino acids, separation of fatty acids from water and toluene, then separation of aromatics from aliphatic, recovery of proteins, enzymes, removal of organics, removal of organics from hydrogen peroxide. Okay, so these are the cases, applications where polymers and resins are used as adsorbent. Next, what are the uses of clay in adsorption? It removes treatment of edible oils, removal of organic pigment, refining of mineral oil, then removal of PCBs, that is polyfluorinated biphenyls. Okay, these are the examples of clay adsorbents. What are the differences between physisorption and chemisorption? So we'll see videos, but before that I'm just telling you, physisorption means physical adsorption. Here the individuality of adsorbate and the adsorbent are preserved. So they, as you have already seen in the video, previous video, that in the physical absorption, the individual property of the adsorbent and adsorbent and adsorbate are not changed, right? But in case of chemisorption, there is a transfer or sharing of electron or breakage of the adsorbate into atoms or radicals which are bound separately. In physisorption, when they happens when intermolecular attractive forces between molecules of the solid adsorbent and the gas are greater than those between molecules of the gas itself, right? In chemiabsorption, it forms chemical bonds like this. So we'll see the video. So you can see here, this is the solid. This is the solid, and here it is the gas molecules and liquids. So adsorption happened. Hello. Okay, so there was an issue. Just a minute. So sorry for the inconvenience. I'm starting again. So where was I? I was showing you this, right? Yeah. So absorptions are of two type, obviously, physical absorption and chemical absorption. So we are telling the differences here. So in case of physical absorption, you see that gas molecules with van der Waals forces between the molecules, and they are attached to the surface, solid substance, right? Addition of dihydrogen on the surface of platinum. So you can see how they are attached to the surface due to the van der Waals force. Unbalanced attractive forces or free valences due to which they are attracted in case of physical absorption. This is the adsorbent, this is the adsorbate. So this is the weak van der Waals force between the adsorbate and adsorbent. Now when chemical adsorption happens, when gas molecules or atoms are held to the surface of a solid by chemical bonds. This is a low temperature van der Waals force for dihydrogen, and in case of high temperature, they are chemically bonded to the adsorbent. So hydrogen atoms are chemically bonded. You can see the chemical bonds, right? So this is the ionic bonding also happens. The ionic chemical bond can be ionic bond or covalent bond. So that is the difference between physical absorption and chemical absorption. And it may occur simultaneously. Okay. It is also a difference. It is more clearly written. So here in the chemical absorption, you can see that only the monolayer of adsorbents are bound to surface by chemical bonding, but in case of physical absorption, it is bounded to the surface by van der Waals force and it is a multilayer. You can see you can just read it out or else you can go through the lecture also. There is also it is written very nice. So this is basically the difference between physical and chemical absorption. Next, chemisorption takes place at what temperature? Chemisorption takes place at what temperature? The answer is 200 degrees centigrade. Chemisorption from a gas generally takes place only at temperature greater than 200 degrees centigrade. Okay. Chemisorption is irreversible. Is it true or false? Chemisorption is irreversible. The answer is true. Once you can also understand that once the chemical bond happens between two molecules, then you cannot reverse the phenomena, right? So chemisorption is irreversible. But physisorption is reversible because they are attached with very weak van der Waals force. Next, the heat of physical adsorption is in the same order of magnitude as dash. The heat of physical adsorption is in the same order of magnitude as dash. Fill in the blanks. The heat of physical adsorption is in the same order of magnitude as heat of condensation. Okay. Next, physisorption requires activation energy. Is it true or false? Physisorption requires activation energy. Is it true or false? The answer is false because physisorption is just physically attachment of the molecules. It doesn't require any temperature or any activation energy. A physically adsorbed molecule can be removed unchanged at a reduced pressure and same temperature. Is it true or false? A physically adsorbed molecule can be removed unchanged at a reduced pressure and same temperature. The answer is true. What are the factors affecting the adsorption? What are the factors affecting the adsorption? So, first one is the effect of nature of adsorbent and adsorbate. First one is the nature of adsorbate and adsorbent. The amount of the gas adsorbed depends upon the nature of the adsorbent and the gas adsorbate which is to be adsorbed, right? Obviously. Second one is the surface area of the adsorbent. The larger will be the extent of adsorption with the large surface area of the adsorbent under the given condition of temperature and pressure. Third one is the temperature, effect of temperature. Third one is the effect of temperature. So here temperature is important for affecting the adsorption because La Chatelier's principle, according to La Chatelier's principle, the decrease in temperature will increase the adsorption and vice versa, right? And fourth one is, of course, the pressure, effect of pressure. Next question. The required residence time of the operation is mainly determined by what? The required residence time of the operation is mainly determined by what? The required residence time of the operation is mainly determined by how fast equilibrium is approached. How fast equilibrium is approached. Next, what are the factors determining the number and arrangement of fixed beds? What are the factors determining the number and arrangement of fixed beds in fixed bed adsorption? So what are the factors? Total feed flow, total feed flow rate, allowable pressure drop, then energy demands, length of mass transfer zone, length of mass transfer zone, method of adsorbent regeneration, method of adsorbent regeneration, and obviously the capital investment. So these are the factors who choose the number and arrangement of fixed beds. Next, What is regeneration of adsorbents? What is regeneration of adsorbents? So, what is regeneration of adsorbent? That means adsorbent particles have finite capacity or for fluid phase molecules, right? An extended contact with the feed fluid will ultimately lead to the creation of a thermodynamic equilibrium between the solid adsorbent and the fluid phases. At this equilibrium condition, the rates of adsorption and desorption are equal and the net loading on the solid cannot increase further. Therefore, it is necessary either to regenerate the adsorbent or to dispose it. So this is the reason for regeneration, right? And what are the regeneration and desorption methods? How they are regenerated and desorbed? Uh, increase in temperature, increase in temperature, reduction in partial pressure, then reduction in concentration, purging with an inert fluid, displacement with a more strongly adsorbing surface, and changing pH or changing chemical conditions. Okay, so this is how regeneration of adsorbents can happen. Okay. Next, explain the difference types of fixed bed adsorption processes. So there are almost 5. Pressure swing adsorption, PSA, temperature swing adsorption, inert parts swing regeneration, vacuum swing adsorption, displacement purge adsorption. Okay, some of the videos I will show. This is the pressure swing adsorption technology. It's to separate various gases from air. As we all know, ambient air, 21% oxygen, 78% nitrogen, 0.9% argon, 0.1% rare gas. That means this technology can be used to separate nitrogen and oxygen gas, which are used for various industrial and cutting industries, chemical manufacturing, food packaging, wastewater treatment, and the treatment through this technology is used to separate oxygen as well as nitrogen. However, the term pressure swing absorption. Around 5 to 10 bar, or in some cases even more higher pressure can be required, roughly depending on the output capacity, roughly around 14 to 14.5 psi makes 1 bar. So anywhere around 70 to 150 psi is needed for separating oxygen. The next word is swing. In this process, 2 tanks are required. When one tank is being pressurized, another tank is being depressurized. That is why the word swing is used, because the compressed air will be swung or moved from one tank to another. The fourth and the third word is adsorption, means something has to be absorbed. Obviously, if you are producing oxygen, apart from oxygen, other gases or atmospheric, they are very similar to absorption for producing oxygen. Zeolite is that adsorbent. So naturally, zeolite some minerals that contain mainly aluminium and silicon compounds. They are used as drying agents in detergents and in water and in air purifiers. It contains micropores that absorb nitrogen from air. That is why zeolite is used in this technology for the production of oxygen. It is because of this adsorbent oxygen gets separated from air. That is why zeolite is also called as molecular sieve. You must have seen sieve, like we use it. At molecular, zeolite separates material molecular level. And now we see the how PA to pressurized tanks or vessels at the bed level of these two tanks, zeolite pellets are placed. As I have said, it will act as an adsorbent. Now the process starts like this. Dry compressed air is blown through a valve to the first vessel where the pressure inside the tank is built to reach around 5 to 10 bar, anywhere around 7 to 150 psi. Since we don't need nitrogen, the unwanted nitrogen gas is adsorbed by the zeolite. During the building of pressure and it settles at the surface of the tank, when the first tank is almost full, nitrogen gas absorbed in the first tank settles down at the bed of the vessel. Later on, it is released into the atmosphere or caught for other purposes through a valve. While the first tank is absorbing nitrogen and the pressure is also building up, at some point it will get full when the first tank is full. The pressurized oxygen is caught through an outlet while the first tank is removing nitrogen. The pressure in the first tank will slowly reduce with the help of a valve compressed the valve compressed air with a valve. Compressed air is then directed into the second tank by shutting the inlet of the first tank when slowly pressure decreases in the first vessel and the zeolite becomes saturated with nitrogen. The waste product is exhausted through the exhaust system. Simultaneously, pressure in the second vessel will slowly build up due to incoming of compressed air. Even in the second tank, nitrogen will settle down due to the presence of zeolite. Now, this entire cycle is controlled electronically in such a way that when the pressure of the first tank goes down, the pressure of the second tank will be up and vice versa. This process guarantees a continuous flow of oxygen. You don't have to wait for one tank to become empty and then start the whole cycle again. This cycle is then repeated under electronic control system in order to produce high purity and stable oxygen continuously. It is a good process of separating oxygen. This is why pressure swing is happening. That is why it is called pressure swing absorption. And 90% pure oxygen can be get. Right? Next. This is the temperature swing. So hot nitrogen or carbon dioxide are coming, heat transfer is happening, it becomes cold and CO2 absorption is happening here inside the chamber. So they are absorbed and nitrogen is out. CO2 is absorbed and nitrogen is out. Here CO2 desorption is happening. Now it leads to CO2 out. So that is how they are separating nitrogen and carbon dioxide by absorption, by temperature swing absorption. Okay. This is your temperature swing. Next one is the difference between vacuum swing adsorption and pressure swing adsorption. So they are saying that why oxygen separation is important. We already know that could be soaked into water and sponge. The molecular structure of both the sponge and the water stay separate but stay combined into one solid object in the absorption process. The objects can easily be separated. The water can easily be separated from a sponge by squeezing the water out. Adsorption, however, is to bind or attract certain molecules together and remain, and these molecules will stick to the surface. The solid, they will not combine the surface once molecule they can remove and filtered out. And a good way to think is to the compare is to face mask. When wearing a mask, you want to filter out the harmful chemicals in the air. When breathing in a filter, you absorb those harmful chemicals while allowing clean air to pass through. The undesired molecules will stick to the filter, so you don't breathe them in. When you are done with the mask, the chemicals can be cleaned or treated to remove the so how oxygen is concentrated. How to catch the nitrogen is one of the problem to separate oxygen. The nitrogen oxygen separation, a material called zeolite, which is highly attractive to nitrogen gas, is used by capturing the nitrogen. The result is a higher concentration of oxygen gas. Now, with the right materials, all that's needed is the process. There are two industry processes commonly used to accomplish oxygen concentration. The first is called pressure swing absorption. The idea behind it is that if you put gas molecules under enough pressure and force them to stay together, the gas molecules will be attracted to solid surfaces. The higher the pressure, the more molecules you can force to adsorb onto the solid surface. Once the desired gas is filtered out, depressurizing the concentrator will release the molecules stuck to the absorbable solid surface. Basically, you are using pressure to attract the molecules and releasing that pressure to clean off the solid plate. They were stuck to in nitric oxide application, natural air would be sucked into the air compressor. From there, air would be pressurized to around 4 to 8 bar. To put it into perspective, 4 to 8 bar is around 400 kPa to 800 kPa. The air pressure at sea level is 101 kPa, and that's 4 times the normal air pressure experienced on land to get to 400 kPa. Naturally, you would have to swim around 40 meters under the surface of the ocean under pressure. The that would attract the nitrogen to its surface and allow the oxygen and argon to pass through. Once the oxygen had been separated from the air, the pressure would be released to form normal atmospheric levels, and the nitrogen would detach from the zeolite. The amount of pressure placed on the air and the compressor would determine the purity of the oxygen produced. As such, the pressuring process is both the means to force the nitrogen and stick to the zeolite plate, the means to clean off the plate once the air is separated. While an effective process pressure absorption is that it constantly needs a high amount of energy to compress and decompose. Right? So for pressure swing, we need high compression. You need high compression, high energy to compress. That is why the high energy cost also considered that constantly subjecting right place to high amounts of pressure means that the equipment will need higher amounts of maintenance and regular replacements, all of which cost money. The second industry process is called the vacuum swing absorption. While like pressure swing absorption and then that it uses zeolite, it is more cost effective in comparison as it uses less energy and requires less maintenance to produce an equal oxygen output. The main difference between processes is that while pressure swing absorption uses pressure to clean off the zeolite plate, vacuum swing absorption uses a vacuum process. Remember that as a state gases like to move and occupy space whenever possible. Think of whenever possible. Think of your space is just as its name space. Space doesn't have any gases floating around like on Earth. The spaceships are concentrated like containers full of compressed trapped gas. When a hole is made in that container, that gas now has a lot of space to expand into. In this case, space is a vacuum and sucks out the oxygen from the spacecraft. It is the same vacuum process that vacuum swing adsorption uses to clean off the zeolite plate. Vacuum swing adsorption uses a blower instead of an air compressor. An air compressor forces concentrated air at high speeds through a hose blower works by blowing force at a high velocity. Its job is to make positive pressure above the vacuum or the atmospheric pressure. The big difference between the two is that air compressors operate at high pressure ratios while blowers operate at low pressure ratios. As such, the need for all the equipment such as dryer, filter and buffer tank is pressure swing adsorption is eliminated and less energy is needed as a result the air is forced into a slightly higher than normal pressure state of 1.25 to 1.5 bar or around 125 to 150 kPa. The nitrogen will adhere to the zeolite and the oxygen will continue to pass through at this pressure. Once the oxygen has passed, a vacuum state will be created. The vacuum state will release all the nitrogen of the zeolite plate and reset the concentrated to restart the process. What's great about this process is it eliminates the need to keep a constant high low pressure to constant high low pressure to produce the same quality of oxygen, which lowers overall operational and maintenance costs. The vacuum swing adsorption process is made viable by using lithium exchange to zeolite. This means that there is a further girth to the zeolite, which means it has a higher nitrogen capacity at lower pressure. While lithium exchange zeolite is more expensive than the zeolite used in a pressure swing adsorption system, lithium exchange zeolite does not need to be replaced as frequently, in part due to its durability and due to its lack of subjection to pressure change, which saves money on maintenance costs. If visualized on a scale, zeolite is kept at a state 101 kilopascal, which is a natural atmospheric pressure. In pressure swing adsorption, the zeolite is forced to the 400 to 800 kPa levels, keeping it under pressure and cleaning the plate off in the process. Vacuum swing adsorption works the other way. It keeps the zeolite at natural atmospheric pressure and then creating a vacuum state of 50 to 60 kPa to clean off the plate. Creating a vacuum environment is less harmful on a zeolite plate, meaning there won't be a worry of needing to maintain or replace the plate as frequently. Oxygen Solutions has developed a vacuum swing adsorption process that was designed for the modular, low maintenance, low cost, and simpler production of high purity oxygen. So now you understood the difference between pressure swing and vacuum swing, right? Last one is the electrosorption. This is an adsorption on the surface of electrode, right? This is an adsorption on the surface of electrode. Okay. Next. In PSA, resorption takes place at an elevated pressure, whereas adsorption occurs at near ambient pressure. Is it true or false? In PSA, resorption takes place at an elevated pressure, whereas adsorption occurs at near ambient pressure. The answer is false. It is the absorption that takes place at an elevated pressure, adsorption, and whereas desorption takes place at near ambient pressure. Okay. How regeneration is achieved in TSA? How regeneration is achieved in TSA? Regeneration of adsorbent in a TSA process is achieved by an increase in temperature. So, when you increase the temperature, the adsorbate will detach from the adsorbent. Next, what are Molex and Zarex processes? What are Molex and Zarex processes? So, we'll now study what are Molex and Zarex processes. So, Molex and Zarex. The Molex is a separation of linear or branched paraffin. Separation of linear or branched paraffins happens here in case of Molex. And in case of Zarex, fructose from fructose and glucose combination is separated. Okay. Here the adsorbent is 5A zeolite. Okay. And here the adsorbent is calcium yttrium combination. Okay. CaY. Here the adsorb regeneration happens for light naphtha. Regeneration happens for light naphtha, and in case of Zarex, it is the water. So these are the two differences between Molex and Zarex processes. Next, what are the methods for commercial sorbent in moving bed system? What are the methods used for commercial sorbent in moving bed system? So first one is the Aerosorb process. Second one is the Aeromax process. And third one is the AdSafe process. Okay. So in the Aerosorb process, separation of aromatics happens. Here from p-xylene, separation happens from C8 aromatic, and here fructose separation happens from fructose-glucose combination. Here the adsorbent is silica gel, Aromax it is X or Y zeolite. In case of AdSafe, it is Ca2 plus resin. Regeneration happens with displacement with pentane, then heavy aromatics, and in AdSafe process with water. Okay, so these are the methods used for commercial sorbent in moving bed system. What are the advantages in moving bed system? The advantage of using moving bed system is that the adsorbent can be regenerated as soon as its role in the adsorption state has been completed. And also heat transfer is better. Okay, so these are two of the reasons why moving bed should be used. Explain the different types of moving bed system. So first one is the simulated moving bed system. Second one is the fluidized bed system. Third one is the pulsed bed system. Fourth one is the rotating bed system. What is cation exchange absorption? What is cation exchange absorption? So you can see it is composed of, or each soil is composed of unique blend termites, its color, texture and storage. So basically cation exchange, it has positively charged mobile ions available for exchange, and it has negatively charged, when it has negatively charged ions for exchange, that is called anion exchange. Okay. So you can see here that is telling a story what is cation exchange. Metals and cations, yes. Most say particles and organic matters in soil are negatively charged. So many nutrients are positive and particles are negative. But in chemistry, you know that opposites attract. The shell of water molecules that forms around the cation, preventing it from bonding permanently. This shell is often called a hydration sphere. And for one potassium cation. So they are changed. You can see that they are displaced. But for nutrients with a positive charge of 2 like calcium, 2 hydrogen cations are needed. The higher the positive charge, the harder it gets to exchange or trade cations. That's because the cation with highly positive charge, small size, is preferentially held by the soil over those with lower charge or larger size, meaning that a large cation with a positive charge of 1 will be the first to be released. So this is the cation exchange. That means cation exchanges are happening. One cation is exchanged with different cations. So in case of ion exchange regimes, we can say there are strong acid cation resins, weak acid cation resin, strong base cation resin, and weak base cation resin. These are four types of cation resins. So in case of strong acid cation resins, sulfonic acid group is used, and in case of weak acid cation resins, carboxylic acid group is used. So sulfonic acid group is used here. Sulfonic acid group. Then here it is carboxylic group. Then for base, it is the hydroxide group. And for weak base, NH2 kind of thing is used, like ammonia. So these videos are explained here. Are mainly the exchange resin with sulfonic acid group, as I have said. The main model is for the high purity water preparation. Okay, this is the sulfonic group. Next one is the ion exchange resins. Okay. The kind of polymer compound with a functional group and active group with exchange ion, reticular structure and insolubility. Usually spherical particles. The full name of ion exchange resin consists of classification name, skeleton or gene name, and basic name, the pore structure. Thickness. The pore structure is divided into gel type and macro type. Macro, macropores and micropores. This is the weak acid cation for water softener. So you can see here that these are the anions, these are the cations. General hardness, the carbonate hardness. How semi-softened water? Because in Ca is reduced. So water softening is the example of ion exchange resin. Here also it is telling about the differences between cation and anion exchange resins. Anion resins are more effective at removing positively charged ions, while opposite case happens in case of cation exchange resins. So these are four types of cation and anion exchange resins, right? So you will go through the videos. Videos will be there in the notes. Next, a typical weak acid resin has limited capacity below pH of 6. The answer is 6. Next, what type of interactions happen in chromatography between molecules? An interaction between the molecules are typical and involve weak chemical bonds like dipole-dipole interaction and hydrogen bond formation and adhere to the stationary components. So when the chromatography happens, chromatography adsorption includes this type of bonds. Next, what are the key factors and types in chromatography? The key factors is partition between liquid, right? Second one is the affinity between molecular weight. And third one is the characteristics related to liquid, solid. Now, what are the types of chromatography? So, there are many, like liquid column chromatography, ion exchange chromatography, gel permeation chromatography, affinity chromatography, paper chromatography, thin layer chromatography, gas chromatography, dye ligand chromatography, hydrophobic interaction chromatography, pseudo affinity chromatography, high pressure liquid chromatography, HPLC. Next, what are the mechanisms of adsorption? First one is the steric mechanism, where the porous solid has pores having dimensions such that it allows small molecules to enter while excluding large molecules from entry. This is very basic to understand. Second one is the equilibrium mechanism. It is based on the solid having different abilities to accommodate different species. That is, the stronger adsorbing species is preferentially removed by the solid. Third one is the kinetic adsorption or kinetic mechanism. It is based on the different rates of diffusion of different species into the pore. The faster diffusing species is preferentially removed by the solid by controlling the time of exposure. Okay. What is Langmuir isotherm? So Langmuir isotherm is, the formula is theta equals to Bp by 1 plus P. Theta is the rate of absorption, B is the affinity constant which has a huge expression, P is the pressure. So this theory allows to understand the monolayer. So this is a Langmuir isotherm equation, and there are many assumptions in Langmuir isotherm, like surface is homogeneous, that is Adsorption energy is constant over all sides. Adsorption on surface is localized, that is, adsorbed atoms or molecules are adsorbed at definite localized sites. Each site can accommodate only one molecule or atom. Gaseous molecule behaves ideally. Only one monolayer forms, no adsorbate interaction, and adsorbate molecule is immobile. So these are the assumptions of Langmuir isotherm. What is Freundlich isotherm and how are parameters varied? Freundlich isotherm is C mu equals to K P to the power 1 by N. So C mu is the concentration of adsorbed species, P is the pressure, K you know is the parameter and N is also the parameter, and K and N decreases with temperature. Okay? And when N is greater than 1, that means the larger this value, the adsorption isotherm becomes more nonlinear as its behavior deviates further away from the linear isotherm. And when N is greater than 10, the adsorption isotherm is approaching a so-called rectangular isotherm. Okay, so these are the physical significance of the parameters. Adsorption kinetics talks about the rate at which adsorption occurs. So it is the rate at which adsorption occurs. Okay. Next, a linear form of PSO. PSO means pseudo first order, pseudo second order. PFO is pseudo first order. A linear form of PSO is favored over PFO model. The answer is true. Controlling adsorptions. There are four mechanisms of controlling adsorption. The first one is mass transfer of solute particle. This is the first mechanism where the mass transfer of solute particle is happened as soon as the adsorbent is dropped into the solution. This process is too fast, thus it is not considered during the design of kinetic systems. Second mechanism, it is called film diffusion. It involves the slow movement of solutes from the boundary layer to the adsorbent surface. Third one is the third mechanism, where when the solute reach the surface of the adsorbent, they move to the pores of the adsorbent. And fourth one is the fourth mechanism. That is, the final mechanism involves rapid adsorptive attachment of the solute on the active sites of the pores. Being a rapid process, it is not considered during engineering design of kinetics. Okay. Now I will show one equation, I will solve one problem. Which is given in the question in your assignment. So the first pseudo first order explanation is there, and you know the terms. The governing equation using the above model by applying the boundary condition for time t equals to 0 to 5 minutes and qt varies from 0 to 2 mg per g is that. So I will do this problem. Okay. So assignment number 10. So the expression that was given was dqt dt equals to k1 qe minus qt, right? Let's check. Yes. Now we'll integrate it, right? Simply, we'll integrate from 0 to 2 because Qt is varied from 0 to 2. QE minus Qt equals to K1 into 0 to 5 dt. It will come minus ln QE minus Qt 0 to 2 equals to K1T 0 to 5, right? Next it will be minus ln QE minus 2 plus ln QE equals to 5 KT, right? 5 minus 0, 5. Then ln QE by QE minus 2 equals to 5K, 5K or 5K1. Better to write it 5K1 or 5K1. This is 5K1, right? Now we are taking minus, so it will be ln QE minus 2 by QE equals to minus 5K1. Now we are changing into exponential. It will be QE minus 2 by QE equals to e to the power minus 5K1. Then 1 minus 2 by QE equals to e to the power minus 5K1. Then 1 minus e to the power minus 5K1 equals to 2 by QE. And finally, it will be QE into 1 minus e to the power minus 5K1 equals to 2, right? So now see which one is coming. QE 1 minus 5K1 equals to 2. Option C. So C is your correct answer. Okay. So that's for today. I hope you will find this lecture helpful, and I have solved one problem also, so you will not have any problem in solving the equation. Rest of the problems are easy to solve.